Hello everyone, and welcome. Today, we're going to demystify a core concept in chromatography, plate height. If you've ever looked at a chromatogram and wondered why some peaks are sharp and narrow while others are wide and spread out, the answer lies in column efficiency, and plate height is our primary way of measuring that. To understand plate height, we first need to imagine the theoretical plate model. Picture your chromatography column not as one long, continuous tube, but as being made up of a huge number of tiny, separate segments. Each one of these segments is called a theoretical plate. Within each tiny plate, the analyte has a chance to equilibrate, or distribute itself, between the stationary phase and the mobile phase before moving on to the next segment. The entire separation is just this process repeated thousands of times as the analyte travels down the column. A column that has more of these theoretical plates will produce a better, more efficient separation. So, what exactly is plate height? Plate height, symbolized as H or sometimes HETP4 height equivalent to a theoretical plate, is the physical length of one of these imaginary theoretical plates. It's the actual height of one of those tiny segments within your column. The single most important takeaway is this: a smaller plate height is always better. A small plate height means that each theoretical plate is very short, which allows you to pack many more of them into the same length of column. For example, if you have a 30 centimeter column with a plate height of 0.1 millimeters, you have 3,000 theoretical plates. But if you can improve your conditions to get a plate height of just 0.05 millimeters, you now have 6,000 plates in the exact same column. More plates mean more equilibration steps, which leads directly to narrower, sharper peaks and a better ability to separate closely related compounds. This is why plate height is the ultimate measure of a column's performance. A low plate height indicates a highly efficient system that minimizes band broadening. It's also important to know that plate height isn't a fixed number. It depends on factors like the mobile phase flow rate, as described by the Van Deemter equation, which helps us find the optimal speed to get the smallest plate height and thus the best possible separation. I hope this explanation helped you understand the importance of plate height in achieving great chromatography. Thank you so much for watching. If you found this video useful and want to learn more, please consider liking, subscribing, or leaving a comment below. Your support helps us create more educational content just like this.